At first light, Devil's Tower does not look like a mountain. It looks cut. The pale columns rise out of the Wyoming grasslands like a shattered trunk, their sides furrowed, their summit unnaturally level, as if some immense cross-section had been left exposed to weather and time. From a distance, the scale breaks the mind before it yields to geology. This is a place millions recognize from postcards, films, and road maps. Yet when the morning fog sits low around its base, the familiar outline becomes harder to explain in ordinary terms. It is not simply tall, it is specific. A cylinder, a grain, a wound in stone. The accepted explanation arrives quickly, and on the surface it is strong. Devil's Tower, according to the official record, is an igneous intrusion. Molten rock forced upward into older layers, cooled below ground. Upwell fractured into columns as it contracted, and was later exposed by erosion after millions of years of surrounding material were stripped away. The rock is identified. The process has a name, columnar jointing. Similar structures exist elsewhere. The timeline fits comfortably inside modern geology. What stands there now is not a stump, but a rare volcanic remnant revealed by water, frost, and deep time. And yet the official explanation, however real its power, carries an unusual hesitation. Even the experts do not entirely agree on the exact form the intrusion once took. Stock, plug, laccolith, diorama of competing models. The broad outline is accepted, but the decisive evidence, by the same account, has been eroded away. That matters, because when a structure looks as physically deliberate as this, uncertainty at the center does not disappear just because the surrounding theory is respectable. It remains, and Devil's Tower is not alone. Across deserts, forests, plateaus, and old volcanic provinces, there are flat-top masses, ribbed vertical walls, severed-looking pillars, and slopes that resemble not random collapse but repeated truncation. So the hidden theory begins there, not as a slogan, and not as a tantrum against science, but as a narrower and more serious possibility. What if some of the formations now categorized only as mountains, buttes, mesas, or volcanic towers are being read at the wrong scale? What if a small number of them are not merely rock that resembles biological structure, but mineralized remnants of an ancient arboreal world so large, so old, and so far outside the biological limits we assume? That the idea was dismissed before it was ever properly tested, that is not proof, it is a question. But it is a question built from recurring form, from classification gaps, and from the strange fact that the more familiar these places become, the less often anyone looks at them as if they might belong to a different category entirely. Begin with shape. Not the poetic impression of shape, but the stubborn geometry of it. A mesa is not only high ground, it is a flat top protected by harder material above softer layers. A butte is that form reduced and isolated. A tower like Devil's Tower is more severe still, vertical sides, repeated polygonal fractures, a summit that reads from the air less like a summit than a surface. Geology explains each of these features separately. Erosion for one, cooling fractures for another. Large differential weathering for the next. But to the eye, and not only to the casual eye, these structures often present as sections, cores, shafts, or cut faces. They look less like uplifted chaos than exposed anatomy. The resemblance alone proves nothing. But resemblance repeated across continents is where investigation usually begins. Then there is the matter of material transformation. Petrified wood is real. No speculation is needed there. Entire trunks have been mineralized, their cellular structure replaced over immense spans of time by silica and other minerals, until wood becomes stone while retaining the memory of wood. In Arizona, fossil logs still fracture into evenly spaced segments so cleanly that visitors ask who cut them. What remains is quartz where tissue once stood. The form survives the substance. This is not an argument that mountains are trees. It is something more restrained and in some ways more unsettling. It is a reminder that organic architecture can cross a threshold into geology and keep enough of its original pattern to mislead, or perhaps to instruct. The stone remembers. That point matters because the official conversation treats petrified wood and mountains as if they belong to entirely separate worlds. One is assigned to paleobotany, museum cases, and hand-sized samples. The other is assigned to geomorphology, tectonics, and continental maps. But nature does not respect departmental boundaries. If mineral replacement can preserve fine botanical detail in a fallen trunk, then scale becomes the forbidden variable. Not because scale alone proves the impossible, but because scale is exactly where inquiry stops. A small fossil wood is accepted. Large rock towers are explained another way before comparison even begins. What changed was the explanation. Consider also the surfaces. On many of these formations, especially those with strong columnar faces, the vertical lines do not merely descend. They organize the entire mass. They produce the impression of bundled fibers or aligned channels under tension. The mainstream explanation for this is that cooling rock cracks in the most efficient way available to a contracting mass, often creating polygonal columns, frequently hexagonal, sometimes five-sided, sometimes irregular. This is a real mechanism. It has been reproduced in lava and observed around the world. But what matters is not whether the mechanism exists. It does. And what matters is that the same kind of repeated vertical organization is also what makes biological structures legible at a distance. Once again, geology has an answer. Once again, the answer may be correct, but it does not erase the larger pattern of resemblance. The pattern does not disappear. The strongest case for the mainstream view deserves to be stated fairly, because without that fairness the investigation becomes worthless. Devil's Tower is composed of igneous rock. The columns match known behavior in cooling magma. Mesas and buttes form through deposition, caprock resistance, and erosion. Entire landscapes can be reduced from plateau to mesa to butte to pinnacle through ordinary geological time. None of that is invented. None of it can be waved away with mood and music. But even a strong explanation can leave blind spots. As it explains the process at the level of rock mechanics, it does not always address why certain forms feel less like random leftovers and more like coherent objects. It can account for individual sites very well while never asking whether some of those sites, taken together, suggest a category problem rather than a local anomaly. That category problem becomes clearer when the scale widens. Devil's Tower is only the most obvious exhibit, which is why it became the symbol. But the same visual grammar appears elsewhere. Isolated flat tops, tapered masses, sheared crowns, radial fracture fields, giant columns standing like exposed internal structure. From the American Southwest to parts of Africa, from volcanic provinces to high plateaus, the same argument repeats in different rock types and different climates. Our mainstream geology says these are unrelated outcomes produced by a limited set of powerful forces acting on different materials. That is plausible. But there is another way to read the repetition, not as coincidence and not as proof, but as recurrence. A form seen once is curiosity. A form seen hundreds of times becomes taxonomy. The question is whose taxonomy has been imposed. Old photographs intensify that unease. 19th century survey images, especially those taken before highways, signage and tourist framing softened the landscape into scenery, often show these formations standing alone with an almost engineered severity. The surrounding country looks worn down. The central mass looks preserved. In some images, the eye does not first register a mountain at all, it registers a remaining object. That a thing still standing after the matrix around it has been removed. This is exactly how archaeologists learn to see a ruin in a field. Not by magic, by contrast, by edges, by form surviving the loss of context. A tower in an eroded basin may indeed be nothing more than resistant rock, but the visual logic of a remnant is still there, and once seen, it is difficult to unsee. Maps add another layer. Many of these sites occur where the surrounding terrain shows signs of immense removal rather than simple sculpting. Vast basins, planed plateaus, stripped sedimentary blankets. In the official story, that removal is the work of rivers, uplift, weather, freeze-thaw, and unthinkable spans of time. Again, that may be right. Yet when one maps the surviving vertical masses against the absent material around them, another image emerges. Not a world being built, but a world being reduced. A world in which the most resistant forms remained after something comprehensive passed through. Investigators of buried infrastructure often begin with absence rather than presence. What is missing tells them what once connected the surviving pieces. Here too, what matters is not only what stands, but what no longer does. And then there is the top. The top is always where the discomfort returns. Mountains usually culminate. They peak, dome, ridge, shatter, or slope away into complexity. A stump ends differently. It resolves into a surface. Not every flat summit means anything. Erosion can level, layers can protect. But when a summit appears abruptly terminated, and when the sides below it preserve long vertical ordering, the mind reaches for an explanation involving truncation. Our geology answers with cape rock or cooled intrusion or erosional surfaces. The hidden theory answers with cutting, breakage, or ancient severance. Between those two readings lies the same object. The dispute is not over what the eye sees. The dispute is over which language is permitted to describe it. This is where skeptics usually object that the scale destroys the theory. Trees cannot reach miles into the air. Their tissues would collapse. Their transport systems would fail. Gravity, wind load, and basic mechanics would make such organisms impossible on the present Earth. And that objection is serious. It may be decisive, but it only becomes decisive if one assumes a constant world, constant atmosphere, constant pressure, constant chemistry, constant biosphere, constant geologic memory. The hidden theory does not survive by denying physics. It survives by asking whether the ancient world preserved in stone was governed by conditions less familiar than the textbooks allow, and whether some of the limits now treated as universal are actually local to the present system. That is a radical claim. It is also the only way the scale question can even be asked without immediately ending the discussion. Notice, though, how often the record itself admits instability in the story. Not instability in the existence of rocks or the reality of erosion, but instability in the finer reconstructions. At Devil's Tower, geologists agree it began as magma, yet still argue over how exactly it cooled and what structure once surrounded it. The exposure of the tower destroyed the very evidence needed to settle the dispute. Already, that should not be overplayed. Science often works with partial remains, but it does create a narrow opening. If the accepted explanation already contains unresolved architecture, then certainty about every competing reading is weaker than it first appears. The record is still there, it is simply incomplete. Another clue lies in language. Surveyors, climbers, miners, and park officials repeatedly described these places with biological metaphors long before internet theories gave the resemblance a program. Trunks, pipes, organ walls, stumps, fibers, grain. These words were not chosen as evidence. They were chosen because the form demanded them. Human perception reaches for the nearest structural analogy available. In most cases, that analogy remains metaphor. But metaphors matter because they reveal which pattern the object presents first. If an entire class of formations repeatedly forces observers into the vocabulary of severed wood and exposed internal structure, then at minimum the resemblance is not the product of one modern obsession. It is built into the encounter. There is also the question of what science chooses to compare. A volcanologist studying columnar jointing is interested in cooling fronts, crack propagation, and fracture angles. A paleobotanist studying petrified wood is interested in tissue replacement, mineral chemistry, and preservation. A geomorphologist studying mesas is interested in caprock, slope retreat, and erosional sequence. Each field is competent inside its own frame. But if a phenomenon crossed those frames, or imitated all three at once, who would claim it? This is how entire categories become invisible. Almost not through dark rooms and sealed vaults, but through ordinary specialization. A thing can be hidden simply by being distributed across disciplines that never gather in the same room. That kind of concealment does not require a dramatic conspiracy. In fact, conspiracy is often the least useful word. Most durable blind spots are made from duller materials: bureaucracy, land management, economic extraction, educational shorthand. The pressure to fit every object into an approved box because mapping, mining, tourism and regulation all depend on stable names. Once a formation becomes a monument, a volcanic neck, a butte, a laccolith, an erosional remnant, its category hardens around it like plaster. Funding follows the label, textbooks inherit it, signage repeats it, children learn it. Our descent sounds childish because the vocabulary was settled before the deeper comparison ever began. Classification can hide more effectively than secrecy. Economics sharpens that tendency. Landscapes are managed according to what they can yield, or aggregate land value, scenic value, heritage value. A stone tower classified as igneous rock invites one kind of survey. A landform classified as erosional remnant invites another. No institution receives grants to test whether a mountain may be misidentified biological architecture from a vanished world. The question falls outside utility. That does not mean the question is true. It means there is little machinery designed to answer it. And what does not fit the machinery is left to amateurs, mystics, satirists, or obsessives, which makes dismissal easier and investigation rarer. The repeated pattern is what keeps the theory alive. Not one tower, not one mesa, not one photograph. A pattern of vertical grain, of flat truncation, of isolated survivors rising from stripped terrain, of real petrification at smaller scales proving that substance can change while structure survives, of official explanations that are often persuasive in detail but segmented in scope, of unresolved edges in the record where erosion has removed the deciding context. None of this proves that mountains were once giant trees. It does something more dangerous to certainty. It makes the idea legible. It gives the theory a structure. And once a theory has structure, dismissal is no longer an argument. There is a final discomfort here, and it is less geological than historical. Such as modern people are trained to believe that the ancient world was simpler than the present one. Smaller forests, smaller animals, smaller engineering, smaller horizons. The deep past in that story is a place of scarcity and gradual development. But the ground often says the opposite. It preserves gigantism, sudden burial, vanished climates, immense biological abundance, and transformation so violent that organic and mineral categories seem to fuse. If some fragment of that older world survived in forms we now call mountains, then the true scandal would not be the existence of giant trees. It would be how completely our explanatory system was arranged to keep such a possibility unserious. Maybe the theory is wrong. Maybe every tower, mesa and flat-top giant on Earth can be accounted for by magma, sediment, uplift and erosion, and each in its proper place, each without remainder. But even then, something would still need explaining. Why do these formations so often resemble severed growth rather than shattered stone? Why do their surfaces read as organized interior rather than mere exterior weathering? Why does the official story, strong as it is, so often rely on missing context, removed overburden, and evidence erased by the very processes it invokes? Those are not the questions of a zealot. They are the questions of anyone standing in front of one of these places long enough for the label to stop working. Look again at Devil's Tower, not as a meme and not as a monument, but as an object. An upright mass of ordered columns, exposed after miles of cover, were stripped away, still carrying on its face a pattern that reads like structure rather than accident. Then look outward to the buttes, the mesas, the isolated crowns of stone standing above emptied country. One by one, each can be named and explained. Together, they begin to feel less like scenery and more like survivors. That is the point where wonder becomes doubt, and doubt becomes pattern recognition. Perhaps mountains are only mountains, perhaps the old names are sufficient, but perhaps some of what we call geology is the graveyard of a biology we no longer know how to recognize. What remains is not certainty, What remains is a persistent mismatch between form and explanation, between what the eye sees and what the category allows. The pattern does not disappear. It only waits for a language able to hit it without embarrassment. And the real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.